Yeah, the configuration of OSPF is a little bit different from the other protocol. The other protocols like EIGRP and RIP, we don't have an option to configure under interface. For OSPF, you can do both the ways. The classical way under the router OSPF and also the interface mode. Whichever you're convenient, you can go. Both are going to do the same work. When you do it under the router OSPF mode, we need to mention the wildcard mask, which you no need to do when you do under the interface. As we all know, OSPF uses a process ID to identify the instance of the OSPF. How many instances we can run? Actually speaking, there is no need for running more than let's say, even in a big environment, I have not seen much. So there is no need to know about how many, even though it may say 65535. It's not necessary to talk about that, because you can create as many as you want when there is a need arises. Why do I need to run more than one OSPF? You see, for some reasons, like you have some customers connected to your edge router. You are a provider. You want to keep the customers' route updates separate. Then you need to create multiple OSPFs. For each customer, one OSPF with different process ID. The route update received by one OSPF won't be advertised via the interface, which is a member of another OSPF. For example, let me draw and explain. For example, if I have a router, this is my inside network, this is towards the customer 1, this is towards customer 2, this is towards customer 3, and this is my inside. Inside my organization, I run OSPF. Between customer 1 and the edge router, we run OSPF. Likewise, customer 2 and edge router, we run OSPF. Now customer is also running OSPF. So using OSPF, he is giving all his routes. I do not want these routes to go via this link. I don't want that. What we can do is we can assign this interface and an OSPF process ID 1, OSPF process ID 2, process ID 3, OSPF process ID 4. See, you got 4 OSPF. So the updates coming here will be seen in the routing table, no doubt, but won't be advertised via this interfaces. Likewise, the update coming from this customer will be seen in the routing table, but it will not be advertised. Via the other OSPF interfaces. You see, the process ID helps us to keep the the OSPFs update separate. If you wish to advertise customer 1 route to customer 2, then you need to do what? Redistribution. Because they are in two different OSPF process. It's two different OSPF simply. To separate OSPF. This customer will have his own area 0. Customer 2 will have its own area 0. Everyone has got our own area 0. So this is different autonomous system. This is one autonomous system. This is another autonomous system. Different autonomous system. So if you want to ping from customer 1 to customer 3, definitely you need redistribution on the edge router. So this is an example to say why we need more than one OSPF. So when we configure OSPF, whether you got more OSPF or one OSPF, you must specify a process ID, which is not necessary in ISIS link state routing protocol. See why I'm comparing ISIS? There is also a link state routing protocol like OSPF. But for ISIS configuration, the process ID is not mandatory. If you have only one ISIS running, then you don't need to mention a process ID, but in OSPF it is mandatory. That's what you see here. Now, I was giving you an example with multiple customers. To keep the routing table separate, we'll need VRF. So we will not focus on this now. We'll come later when we are in MPLS class. So process ID, you can have up to 65535, but it doesn't mean that your router will have 65,000 OSPF running. No, that is just for, you can use your own convenient number as a process ID. But you can create OSPF as many as possible. Not possible, as many as you want. Next, inside OSPF, see you are inside OSPF now. We need to specify the network on the interface by giving the network command, followed by wildcard mask to match the maximum prefix length that you want to match, and the area ID. For example, if you want to run OSPF on 10.1.1.0, 10.1.2.0, 10.2.1.0. Now if you wish to run OSPF only on this two, how I need to configure? I want to run OSPF only on this two. Then what should be my configuration? It should be network 10.1.0.0 wildcard mask. I want to match these two. So 0.0.255.255 area, whatever the area you want. Finished. Now will OSPF run on this link? No. Why? You have said the first octet and second octet need to be 10.1, which is not matching here. It is 10.2 here. So OSPF won't be running on this wire. No hello packets will be sent. No nothing. No neighbor will be discovered. No hello packets. That's why we need wildcard mask. This is one method, ancient method, classical method, the old method. The newer method is you no need to worry about this wildcard mask. You go straight to the interface and say whatever the subnet in this interface, that doesn't matter for me. I want OSPF to run on this interface. So you say IP OSPF 1 area and the area to which you want to put this interface. See, you may have a router which is an ABR where one port is in area 0, another port in area 1. So you will go to this port and say IP OSPF process ID 1 area 0. Whereas on the other interface you will say 1 here. Again, it is an optional method, but most of the time I use only this optional method. I don't use this one. Unless I have a group of interface to be configured in one. That also I will use range command. So mostly you will see me doing this, but for today labs, in labs I will use both. You can mix both in one same router. For example, if you see in this example, they are showing you the classical method, not the optional method. See, this is what they configure. They say any interface that has got 10 in the first octet, put it in OSPF area 0 and run OSPF. So OSPF is now going to run on this link. And they go to this B router and say run OSPF if the interface have got this all 4 octet same 10.2.1.2. 10.2.1.2 is where? Here. So now OSPF is going to run on this port, serial port. Okay, this configuration, this is applicable for this as well as for this, but here they have separately for B. Earlier I was saying for B, no, it's not for B. It is applicable even for B, but this for A. This example shows that the network portion need not to be accurate. You know, to be exactly same on all 4 octet as it is there in the interface. This is to say that if you are using wildcard mask all 0, then it needs to be exactly same. And this one, see, you can also type this one instead of this 2. No problem, because both belong to area 0, both start with 10. It's okay, but they're just showing you the differences, different way of configuring. Now when you're having multi areas, you need to put each interface in different area. You may use the classical method or a newer method or mixed like this. This is mixed way. You see, we go into the serial interface and say, I don't know what IP address and what subnet mask is. I just want OSPF area 1 to run on this interface. See, we don't need to worry about wildcard mask here. We just go under the interface and put IP OSPF. Process ID, area ID. Another interface also needs OSPF. Here also you can repeat the same thing. You can just copy this and paste it here for this interface. But here they are showing you that you may want to do the classical way and the optional way. It is possible, it is allowed. 10.64.02, which is going to run OSPF. Here this is the traditional method, this is the option method. Right, now in OSPF, loop avoidance is mainly because of router ID. Router ID helps to prevent loop. So, for example, if I share something with one of you with my name written on it, you don't know from where the packet is coming, and you see the name. It says my name. Okay, as soon as you see my name, you understand, okay, this is coming from him. Now, if I need to distribute this, I should not distribute to Jay because he only sent me this. So you will distribute to all others. What if all others forward it to me? Loop. In case they won't forward, in case if they forward, they won't forward because we are going to have something called DR, BDR. We'll see that later. That is also part of loop prevention. But if they send by default, for some reason, if they will send my data back to me, if anyone will send, I'll know it is my own data because the router ID will be always attached to the OSPF route updates. It will be always there. Yeah, so the router ID helps to avoid loop. If I take the update, then loop will occur. I ignore because the router ID is attached. In that way, the loop won't occur. Fine. How this router ID is elected? Is it elected or configured? Actually speaking, the preference is given for configuration of router ID. If you're configuring router ID, you need to configure right in the beginning itself. When you configure, before you configure the interfaces, if you configure router ID, it is preferred, it is good. The router ID is just like, IPv4 address. I am not saying it is IPv4 address, it is like an IPv4 address, which is having 32-bit reservation. Router ID is how many bit? 32-bit. With the 8-bit in each octet, means four octets. Same, that's why I said it's like a router ID. So you give a router ID, that ID is just an ID. That need not to be there on any interface. That address that you specify as a router ID, it is not really an address. It need not to be an address. It need not to be there on any of this interface or any of the router in this topology. If it is there also, nothing wrong, but not mandatory. So router ID can be some 4 numbers in that 4 octet. It need not to be there as an IP address on any of the interface. That's one point. Now if you don't want to give manually the router ID, OSPF will say, fine, no problem, I'm going to pick one address as a router ID dynamically. Now which address I will pick? I'll pick the address which is there on the loop back interface. That's the second preference for router ID. What's the first preference? Giving manually. But if you don't configure manually, the second option is loop back interface address on the loop back interface. Now question to you, what if I have 2 loop back interface with 2 different IP address? Answer. I have 2 loop back interface with 2 different yes. Highest IP address. It's not highest number on the interface. Loopback 1, loopback 10, loopback 10 IP address. No. Loopback 10 may have sometimes small IP address. So it is only the IP address on the interface. Which interface? Loopback interface. Now, what if I don't have any loopback interface? If you don't have a loopback interface, physical interface. If you have multiple physical interface, again the same rule as you said, highest IP address from the physical interface. So this is how a router ID is elected. Now, I told you in the beginning of the session that OSPF can be many instances in a router. OSPF, you may run many instances in a router. I said that each instance need a unique router ID. Each instance need a unique router ID. Let's say you got a router with loopback 0, 1.1.1.1, with loopback 1, 2.2.2.2. And when you configure OSPF 1 and OSPF 2, when you configure OSPF 1, this is going to be the router ID. Because you did not configure manually any router ID, it will pick one from the loopback and it will be the largest. And when you configure another OSPF 2, the process ID is what? 2. It won't use the same router ID which is already taken. It takes another one. Even though it is lower, because the highest one is already given to OSPF 1, that cannot be used because this is a router ID. This need to identify the OSPF globally. Process ID identifies the OSPF process locally, but the router ID is global. The neighbor will receive the update with the router ID on it. What if I create a third OSPF? It won't be active. Why? There is no router ID. There is no address for a router ID. So it will ask you to configure manually. Yeah, it will ask you to configure manually. Or you go and configure loopback interface 2, it will take. I want to show you this. Yeah, we're going to use this. Just two routers to understand the router ID thing. 101.1/32. This I'll put it here. So on router 3, I don't have any loopback interface. Yep, so the consoles on this router 3, interface G0/0, now shut IP address 10.0.0.1 255.255.0. You see, we are not going to give router ID manually. I'm going to say the optional method, you remember, going under interface IP OSPF 1 area 0. Whether you use this optional method or the traditional method, the router ID election is not going to be different. It's going to be the same. So now, because I am putting this command, don't think that it is going to take this interface IP address as a router ID. No. Show IP protocol. You can see now the only address that is available in this router is this. So it has taken this as a router ID. Now I'm going to create another OSPF. See what happens. Router OSPF 2. You see, it says OSPF process ID 2 failed to allocate a unique router ID, so cannot start. This is what I was talking about. Why it cannot allocate? Because the only address that was available is already used. It is already used. Show IP protocol. This is already used. Here there is no router ID. So this is not active. This is not active. You can also type this command show IP OSPF and see the same. OSPF show IP OSPF process ID 2 is not running. Please configure the router ID. Process ID 1 has got this as the router ID. It is running. Yep. So this is done. Let's go and configure a process ID manually. Router OSPF 2. I'm going to say router ID 3.3.3.3. You see? Is this 3333 anywhere on the router? No. Now if you check show IP OSPF, you will see two OSPFs. OSPF 2 is also running now, and OSPF 1 is also running. So this is how, when you have multiple process, OSPF needs more than one more than one router ID. Now in our router 4, I'm going to have I'm going to capture so that I can show you the OSPF packets. Now on router 4, I'm going to say router OSPF, the classical method I'm doing. Router OSPF 1, router ID 1.1.1.1, or let me say 4.4.4. So this time will it pick the loopback interface address? No. Interface loopback 0, IP address is 1.1.1.1. If you're doing manually, you have to do it before you configure the interface. That is good. IP OSPF 1 area 0, area 0. Likewise, I'll go under interface G00. Alright, so I'm expecting a lot of OSPF packets now. Yes, it is. It is showing here the OSPF packets. Okay, so now the OSPF neighbor should have come now by this time. Yep, OSPF neighbor has come. Router 4, the neighbor is seen. Now let me show you one OSPF packet. If you see here the destination MAC address, the source MAC address between these two router, IPv4 is the IP address version. And then this is the total frame size. Time to leave the scope of the packet is just one hop, and the protocol is OSPF IGP. The source address is this. See the destination address. The destination address is 224.0.0.5. And then the updates, it's an update packet. Yep. So this is OSPF packet. I want to do something like, I want to match all the update packets. Okay, only the update packets. For update packet, you remember the update packet, the packet, okay, here you need to see on the header. The packet type is 4. OSPF update. Boom. So these are the update packets. We see only the update packets. I have filtered only the update packets. There is no TCP sync packet, there is update packet. If I remove this, now you see all the packets. If you want to see only the update packets, I click boom and it shows only the update packets. See, there are some updates going to a multicast address. There are some updates going to a unicast address. You see? So it is not always the update is going to be multicast. Let's see from the down. This is the one which is sent as a multicast. Open the update packet. It shows what? It shows LSA type 1. It is advertising the router ID. For 10.0.0.2 we use the router ID 444. I told you, for every advertisement the router ID will be attached. And it is advertising about these things. 1.1.1.1, the metric is /32. The cost is 1. 10.0.0.1, sent by 10.0.0.2, the metric is 1. Let's open the next packet, which is coming from the other router 1. Router 1 is talking about the attached router and the local router's router ID. These are the two neighbors, means local and the attached. It shows different info actually, not the same info. And the router ID, you see the router ID of router 1 is 10.0.0.1. Let's pick another one on 10.0.0.1. Yeah, this is where we see the networks advertised. Metric is directly connected 10.0.0.1. Let's see the one-to-one updates. As one-to-one, router 2 is advertising. This is advertised by router 2. I can see the router ID here. And it is advertising about the subnets that which it knows already. But it puts the router ID and sends so that the receiver won't receive if he belongs to the router ID. It advertises about 10 network with a mask and with a metric. We'll talk about sub later. Yep. So let's quit. What we have seen is how the router ID is elected. Let's go back to our class. Now I was telling that the loopback interface can be used as a router ID. Also I said to be a router ID it need not to be there on neither the loopback interface nor on the physical interface. But what I forgot to say is what mentioned in this page here. The router ID which the loopback interface is going to use I might advertise it, I may advertise it or may not also. It need not to be an address advertised in OSPF. It need not to run OSPF. If in our example, see the router ID of router 4 show IP OSPF, the router ID of router 4 is 44444, but this is nowhere. I got a loopback interface, it won't use it because I manually configured show IP interface. This will not be used even though it runs OSPF. You see, show IP OSPF interface brief. Even though it runs OSPF, it will not be used as a router ID. So to use as a router ID, it need not to be an address in the OSPF database. That is one thing. Another thing is, I may use an IP address, you see, on R4 interface loopback 4 IP address 4.4.4.4. I have this 4444 on the interface, but I'm not running OSPF. Not necessary. Though I'm not running OSPF, I still have it as the router ID. So can someone ping 4444? Let me try showing you. It won't ping. Even though it is available on the next router, it is not advertised because OSPF is not running. It is not in the routing table of router 3. That's what here it says. Unadvertised loopback interface address. It won't be there in OSPF table. It won't be there in the address space saved. You cannot ping it. If you advertise the differences, it will be there in the routing table. It will be there in the OSPF database space. You will be able to ping whatever OSPF can use as a router ID. If OSPF process is already running, router must be okay. Now, for example, when you configure OSPF, you failed to provide the router ID manually. The loopback interface address is already picked as the router ID. It is already picked as the router ID. Now, if you try configuring router ID manually, it means OSPF process is already running and you are adding a router ID either manually or providing a bigger router ID, bigger IP address with a loopback interface, whatever. What needs to be done is, for taking effect, for the new router ID to be taken in consideration, you must restart the OSPF process, either by typing the command clear IP OSPF process, or by reloading the router, or by removing the OSPF and configuring the OSPF. Only then it will take effect. So if you are configuring router ID manually, this is the command to configure, which I showed you. So 32-bit unique dotted decimal format address. So when you type this command and give a router ID, if the OSPF process is already active, then the new router ID will take effect only when you reload either the router or the OSPF process, manual OSPF process. Clear IP OSPF process is the command to change. Let me show you. Currently router 4's router ID is 4.4.4.4. See, show IP protocol. You can see that. Now I want to change the router ID manually. I'm going to give router OSPF 1 router ID 44 or 44 or 44. A big address I'm giving, but it won't take. The command is taken, okay? The command is taken, but it won't use it because already you have active OSPF. This address 4444 is already advertised to router 3. So router 3 knows router 4 as 4.4.4.4, but you want it to be 44.44.44. For that, you need to type this command clear IP OSPF process. It'll ask, are you sure you want to do that? Why it is asking this question, you know? It's going to be a disruptive one because your OSPF is going to go down. And all the router will get a triggered update saying OSPF down, neighbor down, network lost. And then you should say yes. And then only it restarts as a fresh newborn baby with a new name now. Let us check now, show IP protocol. You will see 44.44.44.44. Now if you go back to router 3 and check, earlier it was 4444, 4444 is down, and now 44 is going to come. Actually 444 is down, not loading done. It's old output. Show IP OSPF neighbor, you see. This is dying actually. See the timer, it is dying. 5, 4, 3, 2, go, tata, finish. Now a new neighbor with 44 has come. It's the same router for you and me, but for OSPF it's a two separate OSPF coming from the same address 10002 on same port. That's about the router ID. Do you have any question? Please ask now. Show IP OSPF is a nice command which I was using to show you whether the OSPF is actively running and the router ID. And this output shows that this particular router B is an ABR router. How I know? You see, it is a member of area 0 as well as area 1. These are some verification commands. Show IP protocol, show IP router OSPF process ID. If you are running more than one OSPF, you can type this command. Show IP OSPF interface. Right, let me show you one by one. On router 3, you remember I have two OSPF. I'm going to say show IP route first. It is going to show you both the directly connected and the OSPF learned route. And now I'm going to say show IP route OSPF process ID 1. It shows those routes learned only via process ID 1. And when I say process ID 2, actually we don't have any interface. No updates coming, so nothing. Show IP OSPF is another command. As I showed you earlier, you're going to see two OSPF running, but router OSPF 2 do not have any interface. Router OSPF 1 has got some interface, which is area 0 interface backbone. And then show IP OSPF interface brief. It will show you what all interface runs OSPF and what process ID it belong to and what area ID it belong to. And now you look at this. It says this is a designated router. Who is a designated router? The local. Show IP OSPF neighbor will show you very clearly. It says 4444 is a BDR, which means the local is a DR. About the DR and BDR, we are going to discuss one more time. I remember we discussed this in the previous weekend day class last weekend. We are going to do this one more time. DR, BDR. But if you don't want to have DR, BDR, you see, this is process ID, this is priority. When the priority 1, there will be a DR, BDR election in a Ethernet segment. On a point-to-point segment, when you have a serial wire, it is called as point-to-point segment. In point-to-point, the priority will be 0. Even if you make priority as 1, there will not be DR, BDR because it's not necessary. In our topology, this is also looking like a point-to-point environment. This is also looking like a point-to-point environment. But actually it is a Ethernet, so it won't show point-to-point. When I type show IP OSPF interface, it's going to say it is not a point-to-point, it's a broadcast. So there will be a DR and there will be a backup DR. Backup DR is the one which is having 44, 44, 44, 44 as the router ID. The DR is the local router. Local router. If you don't want this DR, BDR, if you find this is not necessary when you have just 2 routers, that is true. When you have 2 routers, it's really not necessary. In that case, what we need to do is we need to say interface G00 IP OSPF network type point-to-point. We are going to discuss about this shortly. When you say point-to-point, there will not be a DR, BDR election. Interface G0/0 IP OSPF network type point-to-point. You have to do it on either side. Now, when you say point-to-point and check this show IP OSPF interface brief, you can see the process ID and you see the point-to-point. It is not broadcast. And when you type show IP OSPF neighbor, though it is gig Ethernet, you see the priority is 0. For point-to-point, the priority is always 0. And do you see any DR, BDR mentioned here? No. Earlier it was DR here, now it is PTP. And here you had a DR. Let me show you going up on router 3. On router 3 earlier, it was in router 4 only. In router 4 earlier when we checked, it was having status BDR, but now it's point-to-point. Right here also we don't have any DR or BDR mentioned because for point-to-point there is no need for DR, BDR. We'll discuss in detail sometime. So I showed you this command, I showed you this command also, I showed you this command also. This is also seen the network type. Right now the network type should be point-to-point. Let me show you that one more time. Show IP OSPF interface G00. Earlier it was broadcast, now it is point-to-point. Okay, this is also another nice command. Show IP OSPF neighbor detail. I was typing show IP OSPF neighbor. You saw only one neighbor, and you can say detail to see more information. See, there is no DR BDR for point to point. This belongs to area 0. Via this interface, it is in full state. Priority is 0. Right, this is not needed for you. Now DVD, EBITs, and all the stuff. Right, so this chapter was giving you a very clear picture of the basic configuration of OSPF and some verification commands. When we have 4 OSPF process running on one router, and if you wish to advertise one OSPF routes to another OSPF process, you need to redistribute. So it will go from OSPF 1 to OSPF 4, but it won't come from OSPF 4 to OSPF 1 reverse until you do the redistribution. So there is no need for filter. If you do only one way redistribution, it will go only one way. The other way, it won't come. From 4 to 1, it won't come unless you redistribute going inside 1, redistributing 4. So there is no need for filter. Welcome. Any other question? Alright, so let us get into the network types in OSPF. But before I get into network types, I would like to cover a few things which we were discussing a few minutes before, like designated router and backup designated router. I know some of you know very well, but just to remind you, without knowing that, we cannot go further. Let us focus on DR BDR once. Then we will go there. When I have a switch connected to many routers, I want you to test this later. It will be interesting. These are all going to be the router ID. If I configure it as a loopback interface address, it will be dynamically picked as a router ID. We all know that. And on the interface, we have see, they're all under single broadcast domain. You see the same network everywhere. It's a LAN, LAN switch. This is what called as network type broadcast. We are going to talk about network types very soon. So when you are configuring OSPF on those routers that are connected to one common LAN, the middle, to avoid loop, there will be a designated router and a backup designated router. Why is it? Otherwise, you will form loop. Let's say these 6 routers or 6 employees, and we are all working on a project. All the 6 employees are working in a project. And router 3, what it does is, this person is sending a query to everyone in the group. Hey, there's a customer online. He is stuck with this. I was asked to help him, but I'm also not confident to solve the problem. Help please, help please. So he is sending help message, and it is going to everyone. And router 2 will say, he's also an employee, he says, hey all, I'm very busy. See, router 3 has got some problem. Kindly help him. Same problem, router 2 is echoing to everyone. And router 4 says, hey, even me too, I'm outside, I'm not inside the office. Someone help, someone help. R5 is also saying, someone help, someone help. No one is going to help. So no one helps. It's just a duplicate going here and there, here and there. Similarly, when there is a change on router 3, a network is gone down here. If R3 sends the update to everyone, and that everyone forwards it to all other, that will cause a big loop, chaos, same duplication. He thinks that he has got that network, he thinks that he has got net. The update is going everywhere, or when a new network comes up, So everyone claimed that I know how to reach that network. Duplication of update will cause loop. To avoid this duplication, one router among all this will be picked up as a designated router by OSPF. Which one router? The router which has got high priority. Let's say the priority is 10 here. The default priority on the Ethernet link I just showed you, it is 2. Sorry, it is 1. I showed you the default priority is 1. But we went to this interface to change the priority. See, let me show you. Interface G0/0 IP OSPF priority 100. 255 is the maximum. I change the priority. Look at this. On the other side, immediately you will see that priority. Show IP OSPF neighbor. This is point to point. No, let me make it as broadcast. I'll cancel this network type point. Okay, now it has turned to broadcast, back to broadcast. Wait for the neighbor to come up. Look at this, the priority 100 has come here as an update. And there will be a DR BDR election. You know who is going to be a DR? Router 4 will be a DR. Why? The priority is high there. Soon you will see a DR, two-way state. Another 3 seconds. Okay, DR. Start state. A full state. Yeah. So the one whose priority is higher becomes the designated router. So we have set priority 10 here and priority 2 here. Others all have the default priority. Always the one whose priority is higher becomes the designated router. First, actually, it will become a backup designated router. And this router will say, hey, my priority is also bigger than the other. I will be a backup designated router because yours is 10. I cannot become DR. I'll be a BDR. Then if this says, oh, okay, sorry, I'll become DR. And this will promote itself as a designated router. Now, whenever there is a change, say for example, the new network has come here, 13.13.13.13. The update will be sent to DR. So all these routers are called as other routers. Actually, it will be written as DR other. It's not DR, it is DR other. When you say DRs, What does the DRs means? It mean both BDR and DR. That is what DRs. So what happens, when there is a change in the topology, the change will be notified to this address 224.0.0.6. Others will send the notification to DRs using this address. So only DR can listen to this packet which is delivered to this address. I showed you the packets are sent to one hop away. So there is no need for enabling PIM multicasting, no, not necessary. Even if the link is not running PIM, this multicast is only one scope, it is supported. Let's not get into multicasting now. I'm just telling you for those who have that question in mind. Next, now this designated router and the backup designated router only these two knows about this new network called 13.13.13.13. Now, BDR will not say anything about this. It will just learn and keep it. But DR will do what, It will use 224.0.0.5 and send the update as an advertisement. Any packet sent to this address can be received only by backup desk, only by other routers. Other routers only can receive the packet that is sent to this address 224.0.0.5. This avoids loop, this avoids duplication of update. Now what happens if DR goes down? If this router goes down, immediately this router will be promoted as a DR so that if there is any change, this can attend to it. Now DR will be responding, but backup designated router is needed. So what happens is this priority, let's say 0 here. Even though this has got the highest router ID, even though the router ID of router 6 is higher than 5555 and 4444 and the other routers, let's forget about this. So the router ID of router 3 is 3333, router ID of 6 is 6.6.6.6, but this cannot become a designated router nor a backup designated router when the priority is 0. When the priority is 0, what you are saying is whatsoever you are not going to participate in election. So R6 will never participate in election, it will remain DR other. So router 5 will now become a backup designated router. Now let us assume when the DR is already available and backup designator is already available, this R1 with a high priority comes back. R1 with the high priority comes back. If it comes back, even though the priority is higher, this will join other group. R1 cannot retain the designated router's position, role. Why? Because it is just coming up. It has got no updates that was sent from other routers in the absence of R1. So to avoid the lag of information, R1 will just join as other router and R2 will continue as a designated router without any change. R5 will also continue as a backup designated router. There won't be any changes in this. There won't be any changes in this. Alright, so if there is no changes, what does it mean? It means that OSPF DR BDR election is known. Someone complete known.
Preemptive.
Preemptive. Can someone explain what is preemptive and non-preemptive means? Or at least just the word preemptive. What is the meaning of preemptive? So preemptive means retaining the position when it comes back. Non-preemptive means when it comes back, it cannot go back to the earlier position. It cannot retain the position. It needs to simply follow as other router. Yeah. All right. Next, let us continue with our new chapter. Please ask if you have any question before we go to this new chapter. No questions. Now, OSPF supports different type of network types. In NBMA as well as in a non-NBMA. What is non-NBMA and what is NBMA? NBMA is nothing but the cloud, the internet in the middle. Between two sites you got internet in the middle. That internet is a non-broadcast multi-access environment. So you got various sites, in between you got one big internet. That is NBMA. The opposite is broadcast environment. Even within an office, you will have a serial wire. That's another point-to-point network type. So OSPF supports point-to-point, which is one broadcast type, which is one OSPF network type, which I showed you some time back in the demo. Before I was configuring as a point-to-point, there was network type called broadcast. In point-to-point and in broadcast, there was one big difference. What is that? I appreciate that. So, in a point-to-point, there is no designated router, backup designated router. In a broadcast network type, which is also can be called as multi-access environment, broadcast multi-access environment, there is going to be a DR and BDR. Even if I have just two routers with the Ethernet, it is considered as broadcast network type. So there will be a DR BDR. To override that, we did that command IP OSPF network type point-to-point, so there won't be any DR BDR. This we have seen. According to us, we have these two network type with very clear meaning. Apart from these two, there is another 5 network types. Apart from these two, there is another 5 different network types. Those 5 are to be configured only when we have NBMA. What we have seen so far is, this is point to point, this is broadcast because I got Ethernet, Ethernet. Here there will be a DR and BDR. This no DR BDR. So this is 2 different type of networks we have seen so far, network types. But this is within an organization. But when I have something like this, multi-sites, in between I got a network, internet work. This is one site, this is another site, this is another site, this is another site. And we got one internet work cloud. We call this as NBMA, non-broadcast multi-access. We used to connect with a special encapsulation protocol like frame relay earlier. So nowadays we don't use that NBMA. We have migrated to multicasting, label switching and segment routing. But let us just assume you got still that same frame relay. Don't say, oh, we don't have these things, why we are learning. No, we have this in our country itself. Frame relay. Not only in our country, in many countries we still have it. So internally between the ISP sites they have this. I've seen this. Now this is what NBMA example, frame relay or ATM, any transport, ATM and then X.25. These things, if you have in the middle, we call it as NBMA. Now when you have NBMA, there are 5 different network types. You can configure. The default one is called as broadcast. The next one is, the default one is non-broadcast. The default one is non-broadcast. In the NBMA network type, in the NBMA, what is NBMA? Just I finished saying you got a frame relay in between the sites. The default is non-broadcast. The second one is point to multi-point. This too is what well known to every vendor because it is RFC standard. Cisco has got another 3 network types. That is putting these 2 together, point to multi-point non-broadcast. And then simply making NBMA to pretend like a point to point. And then even though it is NBMA, it will pretend like a broadcast. See, this broadcast and this point to point is not this broadcast and this point to point. This is real broadcast and real point to point within an organization. But this is between NBMA, you got a point to point approach and broadcast approach. Like this, we got 5 NBMA network types. So about this is what we are going to see in detail in this chapter. The three types of networks defined by OSPF are point to point within an organization, broadcast. This is connected via a serial link. This is connected via Ethernet. Other than this, we got another 5 types under NBMA. What is NBMA? The network interconnected to more than 2 routers, but that has no broadcast capability. They can't support broadcast. Concepts like frame relay, ATMX.25. So for this non-broadcast multi-access, we got 5 mode of operations. This is simple point to point. Whenever you have a serial interface, it is simple point to point. The encapsulation protocol will be either PPP or HDLC. May also be a point-to-point sub-interface running frame relay. You may have it. If you have done frame relay earlier, you know that we have sub-interface with type broadcast and point-to-point. In the point-to-point, we saw there is no DR-BDR election because the priority will be 0. Even if you change the priority, there won't be a DR-BDR because you got a point-to-point link. When the network type is point-to-point, there won't be DR-BDR election. OSPF auto detects the interface type. When you have a serial interface, immediately it will say it's a point-to-point, auto detect. And the point-to-point will use only 224.0.0.5. 6 won't be used. Only 224.0.0.5. Question please. The next type is multi-access or broadcast, which I also showed you and explained you. When you are connecting through a switch using a Ethernet wire, there is going to be a DR and BDR. All the neighbor will have full adjacency only with DR and BDR. In order to send the packet to the DRs, 224.0.0.6 is used. To send the packets to others from DR, 5 is used. And we just saw this election process. The one with the higher priority becomes the designated router, and the next highest will become the backup designated router. That's what you see here. And this will never become a designated router or a backup designated router because the priority is 0. It will be continuing as others always. If there is tie in priority, then it will compare the router ID. The highest priority is what actually preferred. Only when there is a tie, as a tiebreaker, router ID will come. As I said earlier, for DR election there is no preemption, non-preemptive. I also showed you how to change the priority under the interface. I went and said IP OSPF priority 100. Hope you remember that. 0 means they cannot become a DR or BDR. 1, they can participate in election. You can use any number between 0 to 255. The router that is not a DR nor a BDR will be called as DR other. Yep. Now, up to this much, I know you are comfortable because I just showed you the demo. Now here comes the 5 different network types which we were. for trying to understand, which I just started. So whenever you got frame relay or ATM or X.25 in between sites, we call it as NBMA, non-broadcast multi-access, because the broadcast is not supported. There is no broadcast capability. If broadcast is not supported, even the multicast can't be supported. Now in NBMA, OSPF considers NBMA like other broadcast media. Yeah, it's by default. OSPF will consider NBMA as a broadcast media. What does it mean? In broadcast media only, it will elect on DR and BDR. So, in that perspective, it considers like a broadcast media. In which perspective? Perspective of electing DR, BDR. So, when we have multiple routers connected through frame relay, you can expect this to be a DR and this to be a BDR. Now in that case, if I have hub and spoke, the DR BDR is useless. You see, if the hub goes down, there will not be any connection between these three routers. What is the point of having this DR and BDR? That's why they are saying the DR BDR needs to have full mesh connectivity. If you have full connection like this, as well as like this, as well as like this, then the DR BDR is useful. Even if this goes down, it's okay. We have connection directly from BDR to DR, other to DR, other to BDR. But most of the time NBMA are not fully mesh. Are not fully mesh. Then the DR BDR is of no use. Another one more important thing in NBMA is, I was telling you, the default NBMA mode is non-broadcast. In non-broadcast, there will be DR BDR election. That is one point we learned. Another point is neighbors are not automatically discovered. Not. They are not going to be discovered. You remember in BGP we used to configure neighbor manually. Likewise. You have to put the neighbor command and configure neighbors manually. No automatic discovery of neighbor. Why? Because you are working on a non-broadcast environment. How do you expect a multicast? Hello packets. That's why. So if you are having frame relay, means NBMA, that's what frame relay. You may have a star topology like this. You may have a partial mesh star means partial mesh topology, or you may have full mesh topology. Whatever you have, recommended is full mesh for the default non-broadcast mode. But you say, no, I cannot have full mesh. My company never provides. I just got partial mesh. Or if you say I have only hub and spoke, then don't worry, you have options. These are the options. According to the RFC, there are two options. This is for full mesh, the default mode. This is for partial mesh and hub and spoke. And these three are only Cisco additional. This can be for hub and spoke. This can be for full mesh. This can be for hub and spoke and full mesh. So, sorry, this is not for full mesh. Yeah, this is only for full mesh. Full mesh, full mesh. This can be used for partial mesh or hub and spoke. Right, so again I'm telling you, only if you have NBMA you need all this knowledge. If you have Ethernet wire and you want to avoid DR BDR election, then you may use this one. IP OSPF network type point to point. You may use this option. Though it is not an NBMA, though it is not a serial link, even though it is an Ethernet link, there will not be any DR BDR election. This will have full adjacency. To know that, we have this topic. Other things are not really needed, but we will see all of this. So we just saw that there are 5 different types of NBMA modes available for us to use. Now, what are the differences between these 5 is what we are going to focus down. The differences: when we have non-broadcast as a type, which is the default one, that's one difference, no? It's a default one. Whenever your router connects via a serial wire, and when you run frame relay, it will auto-detect and make it as non-broadcast. When you don't have frame relay, the default encapsulation is going to be HDLC if it is Cisco. If it is non-Cisco, it is going to be PTP, point-to-point, PPP, point-to-point protocol, PPP. Then your network type will be point-to-point. But when you have frame relay as encapsulation, the default mode is non-broadcast. That's the first point. This is a default mode. As we saw in the previous slide, the neighbors are not dynamically discovered. No dynamic discovery of neighbor. We need to do manually neighbor configuration. And as we saw earlier, there is going to be a DR BDR election. There is going to be a DR BDR election. Because there is DR BDR election, your network must be full mesh. And in this NBMA non-broadcast type, the hello packets are not sent every 10 seconds. It is sent only every 30 seconds. And dead time is 120 seconds. The hello packets are sent every 30 seconds and the dead time is 120 seconds. Don't forget. The default hello time is what? What's the default hello time?
30.
In a broadcast and point-to-point environment, the default hello type is 10. Correct. 10 and 40. 10 and 40. But in this non-broadcast mode, actually in this first three non-broadcast mode, the timer is, instead of 10, it is only 30 seconds. And instead of 40, 4 times of hello is what? The dead time, which is 120. 30 and 120. 30 and 120 is the timer for all these three. For the other two, it is 10 and 40 as usual. So we are now focusing on the first one, non-broadcast. Non-broadcast, it's a default mode. No dynamic discovery of neighbor, which means we have to configure the neighbors manually. Only then you can find a neighbor. There will be a designated router and backup designated router election. So the topology that is supported is full mesh. The timers are 30 and 120. Let's go to the second one. Second one is point to multi-point. This is not default, you need to configure. I'll show you. If you have a frame relay, you need to configure by giving this command interface G0/0. Actually, it is done on serial interfaces. So I'm just showing you the command. IP OSPF network type point to multi-point. See, this is the command. Point to multi-point. So we do under the interface, serial interface. That's where you can run frame relay. You cannot run frame relay on Ethernet. Now, the difference is here you put no, here you put yes. Dynamic discovery of neighbor. And there is no DR, BDR, no for this one. No DR, BDR. Because there is no DR, BDR, you can use this mode for what? For partial mesh or hub and spoke. So recommended for hub and spoke. The timer is same as we discussed earlier. 30 seconds is the hello timer, 120 is the dead timer. Right, this is what you will see with every vendor. These three we are going to see is only Cisco. Are you clear with these two? This first two is what? Seen with every vendor. RFC standard.
Yes, I got that.
No questions? Okay.
Sir, full mesh means fully wireless, right?
No. Full mesh means this is full mesh. You see? This is connected to all other three. This is connected to all other three. This is connected to all other. This is what full mesh. All connected to everyone. But here if you see, this is the mediator for this. Everyone needs to go through someone in the middle, that is hub and spoke. If this is off, no communication between these three. But here, if this is off, still you have communication, no problem.
Got it, sir. Thank you.
Welcome. Here this is partial mesh. If this is hop, still you have communication. But if this is hop, there is no communication between this and this two. That is partial mesh. Here it is mesh, here it is mesh, but as a whole it is not mesh. It is hub and spoke. Next. Let's see the Cisco's additional mode. Now if you see this one, if you have a close look to this, you can see this one written down here. And this one is written down here. Do you see that? Close look. That's why I made that voice like that. Close look. Point to multi-point, non-broadcast. Putting this and this together. Cisco has come up with an idea, which is combination of these two which we have learned now. The best of these two is taken. The best of these two. What is the best point in this first one, you know? What is the best point in the first mode? That one. And the best part in the second mode, that one, is put together as this third mode by Cisco. Now, I do not want you to answer the best of the first mode. The reason is you will not say correctly. Because you will not accept it as best one unless I explain. The best one of the first is no dynamic discovery of neighbor. That's the best of the first one. That becomes one of the point for this one. One of the point. What is copied from point to multi-point is coming next. What is copied from non-broadcast? No dynamic discovery of neighbor. Is it a best point? Of course it is best. Why, you know? You got a frame relay in the middle, an untrusted network, and this is India, and this is UAE, and this is China. The three friends are meeting together over an untrusted network. Untrusted network. So neighbor need to be statically configured. That is safe for us. Because in the middle you got what? Untrusted network. That's why dynamic discovery of neighbor is not recommended in an NBMA network. Not recommended. For safety reason. Next. The best of the point to multi-point is no DR BDR. That's a very good point. No DR BDR. As a result, this can be supported. This can be used even in hub and spoke, which means it can be supported anywhere. Full mesh, hub and spoke, anywhere. And the timer is same, 30 and 120 seconds. That is the third mode called point to multipoint non-broadcast. Are you comfortable? Any question? No questions? Alright, let's see the other two now. The other two is having different timer. For this two, the timer is same. 10 and 40, like a normal broadcast. It's not normal broadcast. In an NBMA, we are asking routers to pretend as if it is working in a broadcast environment and form neighbor. So, whatever you know in a normal OSPF broadcast environment, every point will come even though it is in a NBMA. What are the points? Neighbors are dynamically discovered. Timer is 10 and 40. There will be a DR and BDR. So recommended only for full mesh. Whereas here also neighbors are dynamically discovered. 10 and 40. No DR, BDR, and cannot be full mesh because it is point to point P2P links. P2P neighborship, meaning if you have one hub router with some sub interface, this is 10 network, this is 20 network, and you got frame relay, and one PVC is going to a router whose address is 10.0.0.2, another PVC is going to another router whose 20.0.0.2. See, different subnets, that is why point to point. This is one point to point, this is another point to point, different subnets. So that's the major difference. In the first four, the similarity is all neighbor, same subnet. Only in this, neighbors are in different. Means every point to point is different network, not neighbors. Every point to point, different network. That's why you need point to point, because they are. You cannot put it as a multi-point because they are not in same network. This is in 20, this is in 10. So why do we learn this? Depending on our network design, subnet availability, and our expectation, we can pick any one which suits our need. We saw 5 different flavors that you can have in NBMA. You can pick any one of this which will suit your need. This is how you configure. I just configured and show you already. IP OSPF network broadcast, IP OSPF network non-broadcast, point to multipoint, point to multipoint non-broadcast. You can say anything, but it is it's you will have this fully utilized, all 5 different types in frame relay environment, which is not much seen, but it is seen. What do we need here? Most importantly, what we need is, when you have a normal Ethernet wire, usually it takes a DR and BDR because of the election that happens in an Ethernet environment, which you may not like here. There you need to say IP OSPF network point to point, this command. That's the main use case you will see in the production. Apart from that, only when you have some frame relay type of connection, you may need the other types. Whatever I have explained will be much better than what you have in this presentation. You also have the presentation, you can go through it later. But I want to tell you this point again. The subnets will be same for all the neighbors in first four. Subnet will be same only on this. Every point-to-point adjacency will be in different subnet. If you are configuring neighbor manually, this is the command to configure neighbor. If you set priority 0, then the neighbor will never participate in election, like this. All this I am going to demonstrate in our next class. So, point to multi-point, we spoke. Now, frame relay is important for this. So, I'll configure frame relay and then I'll do these things for you in our next class. See, in serial, in point to point, if you see, the subnet is different. Here one, another point to point is different subnet. Only then it can be a point to point. Right? See, there are 3 point to point networks here. So one side you have point to multi-point configured, the other side is point to point. Here this chart shows all the things that we learned in one place. Broadcast type and point to point, the timer will be 10 and 40. All the rest, the timer is 30 and 120. See, in my explanation, this was the first one, this was the second one, this was the third one, this was the fourth one and fifth one. So I said for fourth and fifth, the timer is 10 and 40. Okay, so I'm not saying broadcast. This is the first one, here is broadcast. But in our case, the first one was non-broadcast when we learned, okay? So don't get confused with the table and this sequence. This sequence starts with non-broadcast, not broadcast. But the table, they have sodified. They have made, the order is not correct. No. So in non-broadcast, in point to multi-point, non-broadcast, timer is same. Timer is 30, 120. And the subnet should be same on all these 4 except point to point. For each sub-interface or for each P2P, there should be different network. So this is recommended for partial mesh. And these two recommended for partial mesh. And this is recommended for full or partial mesh, but make sure that there is no DR BDR election. For that we need to set priority 0. We'll talk about that when we go there. And for non-broadcast and for point to multi-point non-broadcast, neighbor need to be manually configured, whereas for point to multi-point, neighbors are dynamic, automatic. No DR BDR election for these two. And for point to point, definitely there is no. These two are RFC, the other 3 are Cisco. Debug IP OSPF adjacency and debug IP OSPF events. These are the 2 commands. I always use adjacency as well as events. Events to troubleshoot OSPF. Only the 2 commands are more than enough to troubleshoot any OSPF issues. Right, we will go there in the command line and we'll test it in our next class. So this chapter was about network types. NBMA 5 types. Without NBMA 2 types. Point to point and broadcast. In NBMA non-broadcast, point to multi-point point to multipoint, non-broadcast, broadcast, and point to point. At last, to troubleshoot, we have debug, IP-OSPF adjacency. Another command is debug IP-OSPF events will show even the hello packets. Right, that brings us to the end of this chapter. Any question you may ask now?